I went to the rooftop of my own building, which is 80-meter tall, and I dropped a ball from 80 meters above the ground to collect some data. And right now I'm going to present to you what I collected yesterday. At 0 second, the distance, the ball is still 80 meters above the ground, right here. The displacement is 0. That's obvious. The absolute value of 0 is 0. That means the ball is still 80 meters above the ground. Velocity is 0. However, acceleration is 9. Oh, we're going to use 10 today. Negative 10. Acceleration due to gravity is always same. It's a constant. Okay. Now let's do the 1. So I'm gonna write these two formula over here. One is velocity, one is displacement. Displacement is, and the velocity is, okay. So displacement and the velocity. Okay. So we want to know at the end of 1 second. At the 1 second is, at the end of 1 second is negative 5. So we write negative 5. Now the ball is now 75 meters above the ground, so you're going to write 75. So the ball is now 75 meters above the ground, so you're going to simply write 75. Okay, at the end of 2 seconds, you're going to put 2. So it's now negative 20. So the ball is now 60 meters above the ground, so the ball is here. Now ball is 60 meters above the ground. Okay, now we put 3 over here. Let's see what happened. 45, negative 45. So the ball is $35 meters above the ground. Okay, so ball is 35 meters above the ground. As simple as that. Now we're going to put 4 over here. Okay, now we get 80. So negative 80. So the ball is 0 meters above the ground. So ball is right here. So it matches what we said. Now let's take a look at the velocity. Velocity at 1 second is negative 10. Velocity at 2 seconds is negative 20. Velocity at 3 seconds is negative 30. Velocity at 4 seconds is negative 40. So the ball hitting the ground right before it hit the ground, the velocity is maximum negative 40 meters per second, or just 40 meters per second down. That's the velocity right here. Acceleration is constant. Okay, now we're going to show you, I'm going to show you the graph. Okay, we are drawing the dt graph. Okay, let's see what happened. Let's call this one y initial. Okay, so y initial is 80. So our y-intercept is 0, 80. That's our y-intercept. So then we can do 20, 40, 60, 20, 40, 60, and 80. So at the 0 second, the ball is at the rooftop. At the end of 1 second, the ball is 75 meters above the ground. At the end of 2 seconds, the ball is 60 meters above the ground. At the end of 3 seconds, the ball is 35 meters above the ground. and at the end of 4 seconds the ball is 0 second above the ground. The distance travel the first second is only 5. The distance travel as the second by the end of second is 20. The distance travel at the end of 3 second is 45. And distance travel at the end of 3 second and the third second is -80. So as you see this dot matching with what I have on the parabola, this is smaller, this is smaller, so this distance is smaller than this one, this is smaller than this one, and this is smaller than this one, this is smaller than this one, this is smaller than this one, this is smaller than this one. Okay, now we're going to draw the velocity versus time graph. Okay, the initial velocity is 0. The initial velocity is 0. So this is velocity versus time graph. So now 1, 2, 3, 4 seconds, and -10, -20, -30, and -40. All right. So 0, 0. That's 1 point. 1, -10. 1, -10, so this is -10 and this is -40. 2, -20. At 3 seconds the velocity is -30, and at 4 seconds the velocity is -40. So does that match with what we said? Yes, the ball is speeding up as it falls. That's exactly what we said. Now we're going to do the acceleration versus time graph. Okay, so acceleration versus time graph. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Okay, and this is 0, of course. So at 0 second the acceleration due to gravity is -10. So let's say this is -10 and this is -20. So at the end of at 0 second it is -10. At the end of 1 second -10. At the end of 2 seconds -10. At the end of, okay, so acceleration due to gravity is constant. Okay, so this is exactly what we said right here. We let the ground y is equal to 0. So this is where y is equal to 0. Right here, y is equal to 0. Right here. So this is actually 0, 0, we can say. All right.